Well, today we're going to talk about statistical interpretation of entropy in the thermodynamics second law. Okay, so we're going to give an example, but before we do that, we're going to talk about microstate and macrostate. So what are the microstate? Microstate is the velocity and the position of every particle in your system. Okay? So you have a lot of microstate because you have a lot of particles, right? So there's a lot, right? And then macrostate, so in the big sense, right? It's your pressure, your volume, your temperature, your number of moles, right? So these are your macrostates. So you look at them collectively, you look at them as a whole, right? So those are your macrostate, right? Having those concepts, now we're going to talk about a coin toss experiment, right? So let's say we have 4 coins, and it has head and it has tail, right? So it can, for each coin, it could be a head and tail, right? So we're going to divide it into the macrostate. So the macrostate, you look at them collectively, so that you can have 4 heads, right? And then you can have 3 heads and then 1 tail. You can have 2 heads, 2 tails, right? You can have 1 head, 3 tails. You can have 4 tails, right? So those are your macrostate, right? But if you look at the microstate, right? So the microstate, there are more of them, microstate. What are the microstate? So the microstate for 4 heads could be, and there's only one case, right? It's all 4 of them are 4 heads, right? But for 3 heads and 1 tail, you have head, 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 tail, and then you can change in position, right? So you can have head, head, tail, head, right? And then you can have head, tail, head, head, right? And then you can have tail, head, 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 right? So 1, 2, 3, 4, right? So there are 4 likely, right? So micro, this is number of microstate, number of microstate, okay? Right? So there are 4 of them. This one has 1. And how about 2 head, 2 tail? So you can have head, head, tail, tail, right? You can have head, tail, tail, head, right? You can have tail, tail, head, head, right? You can have, let's see, so you can have head, tail, head, tail, right? You can have tail, head, tail, head, right? And what else can you have? Tail, tail, head, head. So you have that. Tail, head, tail, head. Tail, head, tail, head. We have that, right? We have tail, head, head, tail, right? So we don't have that one. We don't have tail, head, head, tail. So 1, 2, 3, 4, 5, 6. So there are totally 6 microstate, okay? And how about the 1 has 3 tail? So that one, it's opposite of that, right? So that should be tail, head, sorry, yeah, so tail, tail, right? 3 tail, 1 head, right? And you have tail, tail, head, tail, right? You have tail, head, tail, tail. You have, which one? You can have head, head, tail, 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 right? So there are 4 of them. And this is one, it's just tail, 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 right? Okay, so why are we talking about this, right? So we want to talk about entropy. What is entropy? So entropy, right? So I'm going to change in color instead of erasing stuff here, right? So entropy entropy is the same as saying this. Entropy is the degree of chaos, right? So this is the degree of chaos. Okay? And nature like to go to chaos, right? So entropy in the statistics means that the most probable case, right? So that's the nature. So nature like to go to the most probable state, right? So if you toss the coin, the most likely one that would happen would be this one here, right? So this one in statistics means the most probable, right? Probable or probable. What's the word? Probable, right? Most probable state, right? The most probable state, right? Am I spelling that right? Probable, right? Most probable occurrence, right? So which is this one here, right? So this one is the most probable microstate, right? Yeah. So this is the most probable macrostate, okay? So that's the entropy you're talking about, right? So when you have higher entropy, this one has higher entropy, right? This one has higher entropy or highest, right? Highest entropy here, right? And this one has smaller entropy, right? Smallest entropy in our experiment, right? Okay, how about the second law? What is the second law, right? So the second law basically says the following, right? The entropy increase in any process, which is the same as the process occur, which are most probable, right? So the second law in this case is the process occur, which are the most probable. I'm having trouble spelling this word, probable, right? Okay, so that is the second law when you're using statistics to interpret second law. So second law says that I want to go to randomness, right? So in this case, the randomness is the nature, right? And in the coin toss is that the nature is that I want to, I'm most likely to see the two head, two tail happen more than anything else, right? More than the other macro state. So that's the second law. It says that the process which are most probable is, your second law statement of thermodynamics when you're using the statistical interpretation. All right, so that's all we have today. And